bat. He told me the opening bat and he directly bowled a bouncer on relay by giving a title reading: target, treat and terminate diseases. Fortunately, there were additional words: nuclear medicine, Theranostics and introduction. So I am mostly going to stay on that part of nuclear medicine, Theranostics and introduction. We had a very nice introduction to the entire field through the inaugural event, therefore it hardly needs any introduction to restart the things like that. Now, if we, it's not moving. It so happens I come from the city of Chennai and my college is here in its centenary year. So I thought I will dedicate this brief presentation to my alma mater, the Loyola College. We all know that very high impact, so many people have already made that statement of what nuclear medicine is doing towards tumor and METS imaging and therapy. Because we are essentially on Theranostics, I have more focus that some of these words are applicable to the other areas of the clinical nuclear medicine also, but this has been a boon for the cancer care. Two things have happened in the last 25 years. One is the PET-CT, which came in 2001, so we are nearly in its silver jubilee year and that has really made a very, very big transformation, game changer. And along with that, the medical cyclotrons have also come to be a very commonplace item. It was very nice to hear from this Health Secretary of Tamil Nadu, so many growth in PET-CT centers they have told me. This fine precision imaging, what has been possible, has also helped to ensure we could additionally contribute towards the targeted tumor therapy. Because it's not only the tumor METs being imaged, and now we may be able to carry a suitable radionuclide to even deliver adequate dose through the systemic therapy part itself, and this creates what is known as the targeted therapy possible. The combination of these two is what's made perhaps Prabhu to think of the title of the organizer, that what they had given me. But essentially what's been happening is there are continual advances in the development of the vectors to target the various lesions, the tumors, as well as in the case of the radioisotopes of all suitable energy, particulate emissions, etc. Parallelly along with extremely powerful imaging systems. It so happens that so much has taken place on the imaging system also, but coming from radiopharmaceuticals we tend to remain here, but that has also made both the image quality, quantitation, everything so extremely nice. The real versatility of our nuclear medicine is possible because of the type of the vectors we can have and the type of compound along with the radioisotope that we can make. That's what makes it all great. And this is what happened with the glucose molecule, the molecule of the millennium as it was called by Dr. Wagner. And that particular thing, using the extra amount of the proliferating cycles, using the glucose metabolism, becoming to be the METS imaging thing. Any cancer patient part of it became a very commonplace item of this PET-CT imaging, and the PET-CT arrival and the MCs becoming popular, that became like there is no cancer management without going through FDG, PET like had become common. But we have much more things to do. It was further fortified by biovector based targeting, things like a peptide, you target with a peptide the receptors overexpressed on the tumors, etc. And gallium-68, which has been known all along but got delayed recognition because now medical cyclotrons PET-CT became common, so the germanium gallium generator could be available. So gallium based radiopharmaceuticals to supplement all the FDG what it was doing, that became another major important point towards the Theranostics. So using the same vector, for example, if you are using a receptor binding peptide as the vector, along with the gallium it goes for the diagnostic imaging, and along with a beta particulate emitter like lutetium, you are able to use it, and then you are able to deliver the amount of required thing in what we call as a systemic therapy. Just like many other things are administered, here you are administering this in the intravenously, the lutetium concentrates and comes. So the same vector used for the target imaging with the suitable nuclide, preferably positron emitter, so that the superiority of the imaging of the PET-CT can be availed along with the nice beta emitter like lutetium. That is what has given rise to everything. But for a moment we should not think everything has come totally newly. After all, what we are doing with iodine and iodine 131 is nothing but Theranostics. Post total thyroidectomy, you are actually looking for the mets of the thyroid in the well differentiated metastatic cancers, and those sites, then when you give the iodine, it goes and the mets are killed and then destroyed. So we were already long back doing it, and the same thing applies to the MABG also. But with the new terminology and the system, we have regenerated the Theranostics. Now, the very important first turning point was with reference to the fact known as somatostatin receptors are overexpressed in the neuroendocrine tumors and some other tumors, and for that octreotide peptide we do. I'm very happy we have Professor Muthugal Thakur here sitting here. Indium 111, he did so much in the past years, and indium octreotide was a very well-known one agent for that. But cyclotron or cyclotron isotopes were not common, there were no takers. It had to wait for a very long time, and then now with the PET-CT becoming common, the gallium dotatate for the actual NET METS imaging, followed by the lutetium dotatate. It's become extremely well established. 2018 onwards, it got the recognition as the officially approved one, and then it had become much more common popular. But what gave it different tune altogether was the, castration-resistant prostate cancer, metastatic disease to be treated, and there we have tried to use, instead of the prostate-specific membrane antigens for the antibody going, its enzyme action is being used, and you use an enzyme inhibitor to do the targeting, and that became the turning point. They have done the antigen antibody also in the past. It didn't that well take off for various reasons, but using that enzyme inhibitor model, this has become great, and it got a very early recognition also in 22, very fast, relatively very fast thing that had really made it a turning point, and it's completely stayed. Then, as I said, the versatility of nuclear medicine, there are other materials available, other vectors to go for. You have what is known as the cancer-associated fibroblasts. That FAPI inhibitors can be one thing. FAPI is expressed a lot. If you have an inhibitor, FAP is expressed a lot in many tumors, like for example sarcoma. And then if you have an inhibitor molecule, you can label it again with gallium, you do the imaging. And in fact, the gallium FAPI image for many of the tumors is better than actually the FDG, F18 image, and there are other practical convenience. But from our part of it, the same FAPI with the lutetium can be a nice therapeutic part, and this has also grown I tried to take some small extent of volume being an introductory talk to give a kind of an idea. But then I found I am overwhelmed with so much of the literature part to look at it. So then I decided, let me just take some simple things from one of the papers of the 2024 data, in which our Partha Chaudhary was also a co-author. As per that, it would be coming to somewhere around 10 to 15,000 of the PRNT, that is for the prostate cancer. This first one here is referring to the NET ones. Dr. Venkatesh Rangarajan helped me to do some estimated calculations using the amount of the lutetium sold in India and approximately imported also. Both locally also made, imported comes. So somewhere around 3,500 doses would have been there last year. One of the major center in Bangalore, the HCG, Dr. Kallur gave me the data. They use only the imported material of lutetium. They have had 78 cases of the PRRT done last year. But what is interesting is the growth with reference to the prostate CA management, 10 to 15,000 cases done in the globally, which was the data from the Partha Chaudhary's paper. For India, the estimate was around 3,000, and again the imported material used, Bangalore Center had 113 cases. FAPI is entering in not yet in a big way to the extent of the prostate CA and your PRNT treatment, but there are some issues also in some of the ligands and other parts, but it will grow. It has come, and already a center in that same center in Bangalore has done 120 studies in the other cases, and an estimate for all the other centers in India will be about 60 for the last year. Now it's not only the lutetium, there are also other high LET nuclides possibilities, and two of them at least have been quite well known, actinium-225, the alpha emitter, and terbium-161. They have some other kind of logistics and other issues. Currently, using the imported material in India, about 20 each of both actinium and terbium therapies have been done in the last year. I am thankful to Dr. Venkatesh and Dr. Kallur for this kind of information sharing. So, now what has happened over all this is re-emergence and recognition of nuclear medicine as a clinical specialty. It's not just only like a radiology, a service specialty for which you make reference. Here the nuclear medicine physicians are directly in charge of much of the cancer patients like you. So show what to see what to treat what you have seen. That's the targeted therapy, and then check what you have treated. This is also possible. That's what probably made ambitious Dr. Prabhu to tell me the title Target Treat Terminate Diseases. But as an objective educational system of a seminar and the situation we are in, like, it's probably good to do what is known as a SWOT analysis. I somehow don't like the word threat. The strength, weakness, opportunities is okay. Threat gives a negative impression, like, so I call it challenges. It is SWOT analysis, not the SWOT, because challenges have to be faced, handled, managed, tackled, like, so you will be able to do it. So naturally what comes to be the strength of it. Like, I am sure almost all of the people know very well, did not right. One is around 6 decades success of iodine usage. Prostate CA in the last decade has done so much, and there is wide choice of vectors. As I said, FAPI, there are many more, and high LET radioisotopes beyond lutetium is also possible. And good thing of nuclear medicine is the multidisciplinary expertise coming together, and we also have synergy of corporates, academia, and so many other things. Yes, but we are all radiophysicists, nuclear medicine scientists. We also know what are the problems. Pharmacokinetic features vis-a-vis the half-life of the two isotopes. We use what you use for the imaging and the therapy. Extent of the impact of non-target, because it's systemically administered, so there is going to be some non-target uptakes as well as the excretory organ involvement, and that would have its own thing. Then patient-specific pharmacokinetic features. It's not pharmacokinetics means identical in all cases. Patient-specific issues will be there. So all these put together. Then the target moiety expression itself. We know this particular overexpression is there, but it need not be common or uniform in all the patient cases. That creates the other kind of a problem. So the non-uniformity of the target, the vector expression, the lesion expressing the particular feature, that could also be variable. All of this will put together for the therapeutic thing is an extremely high demand on the purity level of radionuclidic, radiochemical, because it ultimately decides on the safety of the entire procedure. Supply chain logistics, this is applicable because of the half-life and other issues. It's common for all the pharmaceuticals, including for this. When we come to the opportunities part, like, it is actually, partly it will be also like the strength, what you say, like, there is a growth in global support for cancer care, particularly keeping an open mind on all the options possible. That's what gives a very great strength to our field, and we should be able to cash upon it. Advances in the cancer research also giving a better understanding and early detection, diagnostic arrangements coming. We should be able to get the patients earlier on to treat, which will enhance the efficacy and improve the thing, rather than coming to be the last of the given up option and then coming as a compassionate care also. This was also there in much of the things. Personalized medicine option is something which is being focused and which is possible here, because if in a particular tumor patient's case, is he having that and is there particular tracer going there, then whether we can treat. That personalized option is obviously available here. And then of course the synergies and the multi-expertise. The challenges, that's the targets, but instead of what I said as the challenges part, the first and foremost is the dosimetry safety. The dosimetry, when we say it is applicable for all therapy in nuclear medicine, because we always land up expressing in terms of so many gigabecquerels or so activity administered, we don't have the grade dose level which the conventional radiation oncologists use. And that's something, in this case, again, it will be dependent on pharmacokinetics, variability will be there. In turn, it makes it on the safety. Then the intricate decay schemes. Many of the isotopes, very conveniently, we say there is a positron emission, we get a PET imaging done, but there is also other particular emissions or other kind of a decay modes are there. They have some impact on that. So that's there. Then the target moiety expression to be positive, because in a particular patient case, once you have proven it's available, then only you will be able to treat, otherwise it's not. Then of course we need always the approvals, both with reference to the Food and Drug Administration as well as the medical community accepting it. So the requirements processes part of it is there. Achieving ultimately the standard of care to go through, it's again a normal. And then the RA production logistics. Quite a few of the people have already mentioned it, I don't have to repeat it. I just want to put back this slide because this is a slide I used. Partly it is drawn from my last year's Norman Coleman oration, in which I had once again mentioned with reference to these aspects of the therapy when we are doing with radionuclide, and particularly there is a legal obligation to tell the patient about the risk estimation to meet the patient's right. And there the efficacy safety part comes very important. Therefore the entire decay chain of the radioisotopes and its added thing will all be there. And even when you have an app targeting moiety, the entire thing may not be favorable. Patient specific variability is also quite good. Regulations, I told you, we need the approvals, etc. to be taken, and then the standard of care. And that way I am happy Dr. Prabhu has got all the other medical speciality also here, like, it makes it like extremely helpful, like. So the final remarks is the NM Theranostics is here today. That's going to be there. We from the community owe it that it's imperative to ensure the overall robustness of every development so that there are no vulnerabilities. Appropriateness and availability. Availability includes both the access as well as the affordability. I wish to just conclude with a quotation. See, it's continuous improvement is better than delayed perfection. So, but we need to work, but at the same time we have to be like doing a carefully balanced activity so that we are not losing the credibility, but at the same time we are not waiting for such a perfection that nothing is delivered. Because the bottom line is where there is a will, there is a way. Thank you so very much for this opportunity. I am very happy to take any questions at the end of the presentation. Thank you all.
Thank you, Dr. Ramamurthy. I think we can have a couple of questions.
The end, they don't know. Yeah, the end only they